All right, today we are going to learn how to factor. All right, but first, before we do that, we're going to do a recall. Do you remember when we multiplied polynomials, the quantity of x plus 1 times the quantity of x plus 2? And we did the FOIL method of x times x, which was x squared, and x times 2, which was going to give us positive 2x, and 1 times x, which was going to give us 1x, and 1 times 2, which is going to give us 2. And then we gathered up our like terms in the middle, and we added those together. Oops, forgot the square on that, guys. So x squared plus 3x plus 2, and that was our final answer. We are now going to take this final answer and we're going to work backwards and get back our polynomials before we multiplied them, and that would be called factoring. All right, so there are some rules into factoring. You've already learned how to factor the GCF, the greatest common factor. So, and you've already learned how to do diamond problems. So we are going to be doing both of those things first, and then we're going to look at what we have, okay? So I'm going to keep our rules here, and I'll walk through them with you as we do them, all right? Okay, so here we go. Okay, now, we're going to factor, and we're going to factor when a is equal to 1. Well, what does that mean? All right, well, this is a quadratic expression. It's not an equation because there's no equals, so it's a quadratic expression. And the reason we know it is a quadratic is because the highest power in the entire problem is squared. So take that to the side. Highest power, or the highest exponent, is 2, which is squared, okay? That's how you know it's quadratic. If it's a 3, x cubed, that's not a quadratic, okay? All right, so what we mean by a equals 1 is that, remember, we have coefficients that could be in front of x squared and x, and then, of course, just the number that's added. So ax squared plus bx plus c is the quadratic expression. If a is equal to 1, in other words, the coefficient in front of the x squared is 1, we will factor using a diamond method. Now, you remember the diamond method, you would multiply to get the top, and you would add to get the bottom. So let's take a look at how this works. All right, we're going to take the same problem that we actually started with and got an answer to, which was x squared plus 3x plus 2, and we're going to factor it now. So the first thing we're going to do is we're going to put that 1 in front of our x squared if it's not there. Okay? All right, and what we do is we multiply the first and last terms. So we're going to take 1 and the positive 2. Remember, sign goes to the number. And we're going to take those two and we're going to multiply them into our diamond. So this is 1 times 2. And we're going to put a 2 in our diamond. Now remember, your middle term gets added up to become the middle term. So what we're going to do is we're going to take the middle term and we put it right down here. So we're going to take our middle term, a lot of arrows right now, but we're not going to do this all the time. And we're going to put that middle term right there. And now we're going to complete our diamond. And our diamond says, what are the factors of 2 that can add to 3? Well, 1 and 2. All right, we're going to take these 2 side numbers in our diamond that we have completed, and we're going to open up parentheses. We're going to have 2 binomials in here. The first is going to be x all the time because x times x gives us x squared. And the other number is going to be these 2 numbers with their signs. And since these were both positive, it would be plus 1 and plus 2. And those are the factors to x squared plus 3x plus 2. Now to check it, you should always multiply back. X squared plus 1 plus 2 is plus 3, and then plus 2, okay, would be x squared plus 3x plus 2, which is what we had. All right, let's try another one. Are you ready? Okay, actually, let's try the same one, just without all the arrows. All right, so again, we're looking at factoring a equals 1, okay? And we're looking at this. We don't see a coefficient here, so we'll write the number 1. I usually prepare my diamond on the side. I'm going to take 1 times 2 and put it in the top. That's my first and my last terms. Multiply to the top number. My middle term goes on the bottom. I now finish my diamond. Factors of 2 that add to 3 are 2 and 1. So I open up my parentheses. I put x in the first position of each of the binomials. And I put plus 2 and plus 1. And that's how fast this can go. All right, next. All right, so we've got b squared plus 8b plus 7. Now, we're going to look for GCFs, which is greatest common factors, which we've already done. And there are no greatest common factors that can come out of b squared, 8b, and 7. So therefore, we're going to look to make sure that a is equal to 1, and it is. I'm going to write it for now, but the next problems I won't, because for now we're only working with a equals 1, which is this value in front of the squared term. So we're going to take our diamond off to the side. First term, last term get multiplied, that's 7. And our middle term is 8. And then we're going to finish our diamond, and our diamond is going to be factors of 7 that can add to 8, so 7 and 1. We're going to open our parentheses, b and b squared, 7 and 1, they're both positive, so plus 7 plus 1. And it doesn't matter if you put b plus 1 first and then b plus 7. That's okay. You can do that. All right, so that's completely factored. Okay, our next problem is k squared minus 13k plus 40. So right away, I'm going to start my diamond. The coefficient in front of k squared is 1. I'm looking through this. I don't see any GCFs. So I'm going to take 1 times 40 and put it in the top of the diamond. I'm going to take my negative 13 and put it in the bottom of the diamond, because remember, the sign belongs to the term, all right? So the sign in front is what you're going to take to belong to the term. And now I'm going to complete my diamond. I need factors of 40 that could add to 13. So I'm going to come up here and I'm going to start 1 and 40, 2 and 20, 3 doesn't divide into 40, 4 goes in 10 times, 5 goes in 8 times. And then after that, you'd be at 8 again. So you've got all your pairs. So you want to look and see if these two numbers add or subtract to give you a 13. We'll deal with signs in a little bit. So I can get 41 by adding or 39 by subtracting, so this is out. I can get 22 by adding or 18 by subtracting, so that's out. I can get 14 by adding or 6 by subtracting, so that's out. I can get 13 by adding. That's good. So I'm going to take 8 and I'm going to take 5. Now, remember to check these because you want them to add up to a negative 13, but they have to multiply to a positive 40. So we got a positive 40 of 8 times 5, but we do not have a negative 13 when we add. So both of these would have to be negative. And then check. Negative times negative is positive. Negative 8 plus negative 5 is negative 13. So open up your factors. K goes in each first term. So it's k minus 8 and k minus 5. And that is it. And then you can check yourself by multiplying out. Okay, so now we're going to look at m squared plus 2m minus 24. So again, we're looking for GCFs. We don't have any. A is 1 because the coefficient from the m squared is 1. So we start the diamond. 1 times negative 24 is negative 24. Positive 2 goes in the bottom of the diamond from our middle term. We're now going to complete our diamond. All right, we're looking factors of 24. Ignore the negative sign, okay? That could add to 2. So we're just going to list all our factors of 24. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So notice how I go 1, 2, 3, 4 and keep going to make sure they divide in and then get the partner to it. All right, so if I add, I get 25, subtract, get 23. Well, that's not giving me 2. Get rid of it. I add 2 and 12, get 14. If I subtract, I get 10. That's not 2. Get rid of it. If I add 3 and 8, I get 11. If I subtract, I get 5. Get rid of it. If I add 6 and 4, I get 10, but if I subtract, I get 2. So 6 and 4 are my contenders. And it doesn't matter which order you write these. Now, we need it to be a positive 2 when it adds, but a negative when it multiplies. So one of these two have to be negative. And since we need a positive when it adds, we need more positives than negatives, so the negative goes to the 4. So now we set up. M goes in each of the first positions. That's a positive 6, so plus 6. Negative 4, so minus 4. And those are our factors. All right, let's do another one quick. A squared minus A minus 90. Okay. Again, no GCFs. The coefficient of A squared is 1. So 1 times negative 90, remember that sign belongs to the term, is negative 90. And in the bottom here, this is a 1 in front of that A. So that's a negative 1. That's why we're doing this problem, so you can see that. It's not going to be nothing. It's there. You just don't see it, so it's a 1. But you take the sign with it, it's a negative 1. Factors of 90, all right, that would give you a 1. I think the most obvious is 10 and 9. Okay, that will give you 90. That usually pops into your head pretty quickly. Now, it has to be a negative 1 when we add, which means we have to have more negatives than positives. So the negative goes on the 10. Double check. Negative 10 times 9 is a negative 90. So we have A minus 10 and A plus 9. Check it out. A squared, negative 10 plus 9, negative 10A plus 9A is negative 1A. And negative 10 times 9, negative 90. And that's our factors. That's it. All right. Now I'm going to make it a little more challenging. Again, we have 4v squared minus 4v minus 8. We always look for GCF. 4, 4, and 8. I'm thinking 2, 4. 8 won't work because it won't divide into 4. Remember, you want the greatest common factor. So the highest number that divides into 4, 4, and 8 would be 4. So you have to take that out first. So this is our GCF. Now what's left is v squared. 4 divides into negative 4v 1 time, so leaves us with minus v. And 4 divides into a negative 8, negative 2 times, so it looks like a minus 2. You have to keep this 4. 4 times this has not changed the value, it just looks different. So we keep our 4 out here. Okay, it has nothing to do with our diamond. Our diamond is only based on this. So our diamond is the 1 in front here of our v squared. Our 4 is outside the entire quantity. 1 times negative 2 is negative 2. This is a negative 1 in front of that v, so negative 1 goes down here. Factors of 2 that can add to 1 would be 2 and 1. We need a negative on the 1, so we need more negatives than positives, and negative 2 times 1 is negative 2. Keep that 4. Don't lose the GCF. Open up 2 parentheses. V goes in the first term of each. Your diamond here helps you fill out the rest of it, which is negative 2 and plus 1. So your entire answer is 4 times the quantity v minus 2 times the quantity v plus 1. All right, let's try one more like this. 6v squared plus 66v plus 60. 6, 66, 60. Pops in my head as the greatest common factor is 6. So that leaves you with v squared plus 11v plus 10. Your diamond is based only on the trinomial. There's a 1 in front of this v squared. Cover up the 6 with your thumb. It's not there for the diamond. 1 times 10 gives us 10, and 11 as our middle term goes down here. Completing your diamond, factors of 10 that would add to 11 would be 10 and 1. 5 and 2 would not add to 11, so that's out. They're both positive. They'll multiply to 10, add to 11. Everybody's happy. That's a good thing. Our final answer is keep that 6 GCF. Don't let it go. Open up 2 parentheses. v plus 10, v plus 1. And that's your final answer. Again, to check it, v squared, 10v and 1v is 11v, and 10v. And then you're back here. And then this is 6, 66, and 60, and you're back at the top. All right, that's your final answer. So running through, finding how to factor a trinomial where a is equal to 1, always look for a GCF first, and if there is none, resort to your diamond, and then write your factors from your diamond.